Okay, just a little more to go here in the community ecology. Again, island chains are good examples that support this idea of island biogeography. In the Galapagos, you go to the bigger islands, you'll find more species than on the smaller islands. And if islands are closer to the mainland, now of course they're all in the Galapagos, they're all relatively far from the mainland, but you should see the same trend as well if you had some that were quite a bit closer and some that were further away. Okay, so community structure, how is it formed and maintained? And this has been discussed and studied in, over the decades. And so we can think of a community perhaps as in a group of tightly linked species with lots of interactions, or perhaps more of one where they tend to be more individualistic, not so many tight connections between them, and they just happen to be living in sort of the same area. Now, the integrated hypothesis, the one with these tight links, could be seen as this way, and that is across a gradient you'll see certain types. So these types of these species here are very tightly linked, these ones here are very tightly linked, and these guys here are very tightly linked, and they have specific parts of the environment that they really favor. Again, they're all living together in this overall environment, but there are certain sort of little areas within them that they favor, you might say. Whereas the individualistic says that in this overall community there's not so many of the tight linkages between the species. That is, they all have their own little niche, their own little area that they like that isn't really so much overlapping with others. And the latter seems to be more of the case. That is, isn't a lack of connections between these species, but again, because of the competitive exclusion principle and character displacement, the species tend to begin to occupy particular niches, and so this plays a role when we think about these ideas of, in conservation biology, it plays a role because with this scenario you would say, okay, if we remove one of these species, and it's very tightly linked to these others, and they may not do so well if we remove them, whereas this says it's not so much the case because there's not as a close a link between them. And what you can say is that while we don't want to willy-nilly remove species from natural systems, it says that natural systems tend to be relatively robust and will maintain their integrity in spite of certain species not being as prominent or even around. Now, of course, that doesn't take into account keystone species. Again, you can have certain species within that system that do have an inordinate pack, but natural systems tend to be a little bit more robust than we sometimes give them credit for. And so another way of thinking this is what's called the rivet and redundancy model. The rivet model said that species are very tightly linked. A rivet is a little metal rod that holds other pieces of metal together, for example. Whereas the redundancy says that if you, and this first one says if you remove that species again, it'll have significant impacts on that system. The other one says, the redundancy model says that, well, if one species becomes less prominent, less dominant, others will tend to come in and take its place. And so there's still debate about that, the degree to which it's one or the other, and as it's suggested here, there's probably a bit of both, where you might have certain species like keystone species which are more like rivets, but then other things that are more easily replaced by other species. But as Aldo Leopolds would say, he's a famous conservationist and biologist from the early to mid 20th century who likened these natural systems to, say, a watch, and a nice analog watch. Think of a Swiss watch. It's got all these interacting parts. And as he would say, you can perhaps remove one of those parts and the watch still works, but it may not keep time so well. And you can remove another part and, well, maybe it still works, but again, its ability to keep time doesn't do so well. And you get to the point where if you remove enough of these parts, the watch, the system kind of just breaks down and doesn't work so well. And so he thought of this as a good analogy for natural systems, in that if you just start taking out into particular species, you never quite know what's going to happen. And if you really don't know what's going to happen, you probably shouldn't remove them. Just as with the watch, you probably shouldn't remove these parts because it may not work so well. He was a proponent of really having people, it sounds a little cliched, but living a bit more in harmony with nature, as opposed to having a more overbearing attitude towards nature, and we could just kind of do what we want with it, and, well, it'll be just fine, because we don't always know that for sure, particularly if we're not fully knowledgeable of how the system works. Okay, enough of community ecology. Thanks.